This is an asteroid. At least it is today.
Okay, why don't you guys go ahead and slide it under.
At this workshop in California, Alan Lowry and his team are getting ready to test a device that could be flown into space to capture the real thing.
Usually when I tell people what I'm working on, I get a laugh. Like, are you kidding me?
Airborne Systems is the leader in space parachute technology. Their chute slowed the Orion spacecraft on its first touchdown. Now, they're testing their design for NASA's competition to drag an asteroid into Earth's orbit. Once there, astronauts could study it again and again. It's called the Asteroid Redirect Mission, or ARM, and this is the hand they hope will win.
It's a very audacious objective to go out and capture an asteroid. Our concept is to actually totally envelop an asteroid against a robotic spacecraft and then move the full asteroid to another orbit. What does an asteroid look like? It kind of looks like a very large potato. It's an oblong shape, it's got dimples in it, and we kind of started looking at it and we thought something like a hand would be an excellent kind of device. You can't get a better design than the hand.
They don't know what they'll find when they get an asteroid, a dense rock, or just a pile of rubble hurtling through space.
Before we put any forces on the asteroid, it's really important to contain it, because if some of these materials come off the asteroid, they could impact the spacecraft and damage the mission.
There are very few moving parts relative to some mechanical device, rigid mechanical
That's
device.
what you want with a space device. It's very reliable. It has to work. When we first heard about the asteroid mission, we realized that the device had to be very compact for launch, but yet be able to deploy to a very large device that's maybe 50 feet tall and 50 feet in diameter.
So, their fingers were designed to be packed for travel.
An air beam is a braided, inflatable device. It has a gas barrier inside of it, and when it's inflated, it becomes a very stiff and lightweight structural member. As you can see, it has knuckles like a finger does. We've shaped it into sort of a funnel shape because that any number of sizes of asteroid can fit within this device. This will be the first time we've done this with the simulated asteroid. Hope it works. We want to bring the asteroid down until it's about 2 feet above the metallic structure on the bottom. I think that's good.
I'm going to go ahead and start the bag closure.
The ties holding the bag to the arms are supposed to break to let the bag close.
Like, it looks like some of the brake ties didn't break like they were supposed to.
Yeah.
And I guess we'll have to just go to a lighter weight cord next time.
It's a small glitch. After a manual fix, they go in for the grab.
We lower the air pressure in the beam so they buckle easier without loading up the winches more than necessary.
Great. I think it's a very good test for the first time. I'm happy with it.
The ARM mission won't launch until 2019, giving this team a few more years to perfect their hand.
Before. To actually capture an object that's hurtling through space at 25,000 miles an hour and moving it. This will be the first time in history.